put up today's notes. The notes are in Google Classroom. I loaded them a little while ago. So you do have that. We're going to go over them and do them together live here with some sample problems. We're not going to do all the sample problems. There's a whole bunch. I've kind of highlighted some that I want to hit. And we'll see how many of those we can get to without taking up forever today. Okay, here we go. So we're looking at radicals and rational exponents. We're looking at converting things from exponent to radicals. So exponential form to radical form. So if we have, let's see, I've got some of this somewhere. If we have an exponent that's a equals 1 over n, like a to the 1/2 power, right, to the power of 1/2, that means the nth root of a. So 1 over n as a power is the same thing as a to the nth radical, right? So if it's 1/2, this is just the square root of a. If it's a to the 1/3 power, this is the cubed root of a. Whatever the n is what goes above the radical. The square root, the cubed root, the 4th root, 6th root, whatever it is. And if we have m over n, so a raised to the 2/3 power, whatever that is, then the n, we already know the n, what's on bottom, goes outside the radical. And the other is the power that a is being raised to. A to the m power. So the nth root of a to the m power. So let's try that with some. I've got some of these highlighted. So if we're going to write each radical expression and then simplify if needed, first thing I'll do is rewrite it. So 24 to the 1/3 power is the same thing as the cubed root of 24. Cubed root of 24. Now we can simplify that because I saved this from last week. I cut it out so I could use it on my assignment. Perfect cubes. These are all perfect cubes. These numbers are perfect cubes. 1, 8, 27, 64. So can we divide this by 1, 8, not 27, 8. So that's the same thing as the cubed root of 8 times 3. 8 times 3 is 24. So since 8 is a perfect cube, that's 2 times 2 times 2. This is the same thing as 2 cubed roots of 3. Now, just so everyone remembers what a cubed root is, because some of you guys struggled with that on last week's assignment. If I want the cubed root of something, like let's choose 125. I want the cubed root of 125. That means what number can I multiply by itself to equal 125? Because that would be the cube root. If there's a number I can multiply by itself, oh, it's getting too washed out there. Let me turn off that light, see if that helps it. Something times something times something. That equals 125. Well, 5 times 5 times 5 equals 125, because I know that 125 is one of my perfect cubes. It's 5. So this would equal 5. That's what the cubed root of 125 is equal to 5. I have to raise this up a little bit to get it to stop bleaching out on us here. All right, focus in there, thing. All right. So a cube root of something is what do I multiply 3 times to get? And it's not always a perfect number. If it's not a perfect one, like this one, 24 was not a perfect cube, but it had a perfect cube in it, 3 times 8. So 2 times 2 times 2 is 8. So it comes out as the cubed root of 8. Let's look at this one below it here. This says 3 to the 5/4 power. 3 to the 5/4 power. So that means this is the 4th root of 3 to the 5th power. The 4th root of 3 to the 5th power. Well, 3 to the 5th power is the same thing as, let's do this, the 4th root of 3 to the 4th power times 3. All right, remember the rules of exponents? We covered that last week. If you have two powers being multiplied to each other with the same base, like 3 to the fourth times 3 to the first, you add those together, 4 plus 1 is 5. So for this case, 3 to the fourth power, if you're taking the fourth root of 3 to the fourth power, that kind of cancels each other out. That is 3. And then this one has to stay inside because it's just a 3 to the fourth power of 3. So it's 3 times the fourth power of 3. All right. Let's look at this one right here. Negative 6x to the 2/3 power. So first thing we're doing is rewriting that as an exponent, and then we simplify it if we can. So rewrite it as a radical. Radical. So that is the third root, because that's what's on the denominator of, it's in parentheses, so it's all together, negative 6x squared. Negative 6x squared, which we can simplify that as the same as the third root. Negative 6x times negative 6x is 36x squared. Right? So that is the same thing as the cubed root of 36x squared. If we look at our perfect cubes are 1, 8, 27, and then we get up to 36. You can't divide 8 into 36. 1 doesn't do us any good. You can't divide 27 in there. So there are no perfect cubes in that. That's as simplified as we can make that. So 36x squared. All right, let's look at this one over here. 7 times 12w to the 1/2 power. 7 times 12w to the 1/2 power, which means the square root. Now for squares, this is a square root. 12 square roots 1, 4, 9. 4 will go into 12. So we can simplify that as 7. Oh, I got to put the 7 outside first. I was putting my square root. I said 7. 7 square roots of 4 times 3w. And the 4, we can take the square root of 4. So that'd be 7 times 2, because when you take it outside, you got to multiply it by anything that's out there. So now we got 14 square roots of 3w. That's as simple as it gets. We can't take the square root of 3. Can't take the square root of w. All right, let's do some more. These are in radicals, and we have to write them in exponential form. It does not say to simplify of neither. This says simplify. This we're just rewriting. So leave them however they are. Just rewrite that in exponential forms. So this is a fourth root, and it's 8w. So that would be 8w, because all of that is under the radical sign. So all of it would be raised to the power of 1/4. Since that's a fourth root, that means 8w to the 1/4 power. How about 11 squared, the cubed root of 11 squared? Well, 11 squared cube root. So 11 to the 2/3. We take whatever's out here and goes in the denominator. Whatever's in here goes in the numerator. 11 to the 2/3 power. How about this one over here? We have all of this being raised to the 7th power. So inside we have 3m, and it's to the 1/2 power, but all of it's being raised to the 7th power. So that's 3m to the 7/2 power. Okay, this one right here. So we've got everything inside here. 9x to the 7th, y to the 4th, to the 1/3 power. Now we can simplify that. This is not wrong as it is, but since these have exponents inside, you got 9 to the 1/3 power times x to the 7/3 power times y to the 4/3 power. That's the same thing. That's taken, this is being raised to the 7th, but also to the 1/3. So x to the 7/3, y to the 4/3. All right, so that's examples of how to go from an exponent to a radical, and then simplifying a radical, or a radical to an exponent. Okay, so this is what you need to know in your notes. If it's an exponent, whatever the n is goes outside on the radical. Whatever the m is goes inside with the base. All right, let's look at some more problems doing something. This is rewrite all the radicals in exponential form. So we're simplifying expressions. Use the exponent rules to simplify the expression, and then write it as a radical in simplest form. So we start by rewriting it in exponential if it's not already. Some of these are already in exponential. Then we simplify it using our exponent rules, and then write it as a radical for our answer. So this is the same base. They both are x's, and they're being multiplied times each other, which means we can add the exponents. So that's the same as x to the 1/3 plus 4/3, 1/3 plus 4/3, which equals x to the 5/3. So when you have 1/3 and added 4/3 to it, you got 5/3. So we want to rewrite that as x to the 5th, the cubed root of that. The cubed root of x to the 5th. Because whatever's on bottom goes with the radical. Whatever's on top becomes the radicand. X to the 5th. All right, let's try this one over here. I've got this one highlighted. This is a power to a power. A is being taken to the 1/3 power, and 1/3 is being taken to the 5/2 power. So a power to a power, if you remember that, that means you take a to the 1/3 times 5/2. A power to a power, you multiply the exponents. 1 times 5 is 5. So this is a to the 5. 3 times 2 is 6. A to the 5/6 power. We're supposed to write our answer as a radical. So writing this as a radical, we've got a to the 5th power, the 6th root of that, a 6th root. That's a 6, not a b. 6th root of a to the 5th. Let's go down here. It says 100 to, it looks like a negative 1/2. Well, if you remember a negative 1/2, that's the same thing as 1 over 100 to the 2nd power. All right, if we move it to the denominator, it becomes 1 over. Wait a minute, we're rewriting this. We're rewriting this as a exponent. Okay, it's an exponent first, then we're simplifying it, and then go rise a radical. Okay, stop. What am I saying? I'm doing what? No, that's not right. That's not right. Let's scratch this and redo this problem. When we have 100 to the negative 1/2, we simply need to rewrite it as 1 over 100 to the positive 1/2. That's how you change an exponent to a positive, is you move it to the other side of the denominator, right? Negative 1/2, the positive 1/2. And so that's the same as 1 over 1/2 means the square root of 100, right? Because that's what the 1/2 exponent means. So that is the same thing as 1 over, what's the square root of 100? We simplify that to 1/10. It's as simple as that. I don't know what you were doing, but we're fixed now. Please continue like this. 16 to the 2/3. Oh, I didn't have that one highlighted. I'm going down to this one. I think this is one in your homework to do over there. Let's see. We have to, rewrite an exponential form, because this one is not an exponential form. So that's the same thing as v to the 1/3 times v. So v to the 1st power, basically. That's just v to the first. So multiplying means you can add them together. So if I add v to the first power, that's the same thing as 3 over 3. 3 over 3 is 1. But then I can add them and say this is the 4/3 power. So this would be v to the fourth, the cubed root of v to the fourth. And one thing we're going to go over again, because a lot of you messing this up, is how do you put this in formative? Formative will let you do third root, fourth root, fifth root, whatever root you want. Some of you are just using square root every time. Don't do that. Make it look right. Use the correct button in formative. We're going to look at that before we're done here. All right, let's look at number 31. So this is, remember, with the exponent power, you can actually subtract that. So this is 4 to the first over 4 to the 1/3. 4 to the first over 4 to the 1/3. When you have exponents that are divided like that, that's the same thing as 4 to the 1 minus 1/3. All right, which is the same as 4 to the 2/3, because 1 minus 1/3 is 2/3. So that simplifies to the cubed root of 4 squared. And since that's a real number, that's the same thing as the cubed root of 16, because that's what 4 squared is. And then our last one we're going to do on this page is x to the 10/4, right there, 10/4, which we can simplify that because that's the same thing as x to the 4/4 times x to the 4/4 times x squared 2/4. X to the 4/4 is just x. X times x is x squared. X to the 2/4 be x squared with the fourth root. So that simplifies. So there's 2 whole x's in there. Because when you did the fourth root of 10 to the x, you'd have x to the fourth, x squared, and those x to the fourth. So remember that if you was just simplifying that, that's the same as x to the fourth times x to the fourth times x squared. And the fourth root of x to the fourth, see, that would be x times x times x times x. That would equal x to the fourth. So the fourth root is just an x. So you'd have x times x times the fourth root of x squared, which is the same thing as this. All right. So go through those carefully. Here's the last thing we're doing this week is we're adding, subtracting, and multiplying radicals. Now here's how it works. You simplify the radical, and the only ones you can combine have to have the same index and the same radicand. Remember, when you have a number, the n right here is the index. These have to be the same. And the same radicand would be whatever number is right there. Whatever the radicand. Well, we're not taking it to a power. Like whatever the number underneath there has to be the same. That's the radicand. So those we can add and subtract. For common radicals, add and subtract the coefficients and keep the common radical. Treat this like x. Like you had 2x minus 3x be negative x. So if you have 2 square roots of a minus 3 square roots of a, those stay the same. So let's do some examples. 3 square roots of 27 minus 2 square roots of 12. Well, we look at it and we say, well, it doesn't have the same radicand. But can it, if we simplified it, because we have to simplify it first, will it have the same radicand? It does have the same index. They're both square root. They're both square root. So we can do that. But let's simplify. What square root is in 27? 1 does not go into 27. 4 does not go into 27. That's an even number, so this would have to be even. 9 will go into 27. So this is the same thing as 3 9 times 3 minus 2. What can we do with 12? 4 goes into 12. So 4 times 3. We can rewrite that like that. So now we can take the square root of those numbers. So this is 3 times 3, because that's going to come out as a 3. Square roots of 3 minus, this comes out as a 2, right? Square root of 4 is 2 minus 2 times 2 square roots of 3. So we can rewrite this 9 square roots of 3 minus 2 times 2 is 4 square roots of 3. Now we have the same index. They're both square and same radicand. They're both 3s. So this equals 5 square roots of 3.
Do you ever get them like that little, like looks like almost like chalk? It's like this little white thing that they
That's what that equals. 5 square roots of 3. Because when we simplify them, we end up with the same radical. The same radicand and the same index. Square root of 3. So that, yeah, remember, you would treat it like you would x. If you had 9x minus 4x, that would equal 5x. Just in this case, x equals the square root of 3. 9 square roots of 3 minus 4 square roots of 3. 9x minus 4x. Treat those just like they're a variable when you're adding and subtracting. All right, we're going to do number 4. We're going to go down here. 10 square roots of 28 plus 3 cubed roots of 56 minus 4 square roots of 175. So we know right away there's not going to be anything else that we can combine in that, but maybe we can simplify it. But that's the only cube root. These are square roots. Perhaps we can put those together if we can get to have the same radicand. If we can get the same radicand, we can combine those. All right, so let's look and see with our list. Right here, we want to convert 28 as a square, and we want to do 56 as a cube if we can simplify it, and then 175, see if we can pull a square out of that one. So let's see, 28 is a square root, 1491625. Well, 4 is probably the biggest number we can divide into 28. 9 does not divide into 28. 16 does not. 25 does. 4 is going to be the biggest number. So this is 10 times the square root of 4 times 7 plus the cubed root of negative 56. Well, we see that negative 1 and there's an 8. So let's do that. Plus the cubed root of negative 8 times 7. Negative 8 times 7 is negative 56. And we can take the cubed root of negative 8. Negative 2 cubed is negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is 4. 4 times negative 2 equals negative 8. So negative 2 is the cubed root of negative 8. 4 times 175. 175, that's not going to divide into it. 81 is not going to divide into it. 64, 49, 30, 25 will. So there'll be plus, I'm sorry, we're at a minus 4. Minus 4 times 25 times 7. Okay, so we've rewritten them to where we can pull out squares and cubes. So the square root of 4 is 2. 2 times 10 is 20. So that simplifies to 20 square roots of 7. Then we have just plus the cube root of negative 56. We said that negative 8, the cube root of negative 8 is negative 2. Cube roots of 7. And 25. The square root of 25 is 5. So minus 4 times 5, that's 20. Square roots of 7. So what do we have? We have 20 square roots of 7 minus 2 cube roots of 7 minus 20 square roots of 7. These are both the square root of 7, so we can combine those. So 20 square roots of 7 minus 20 square roots of 7. Oh, they combine to be 0. So the answer is just -2 cube roots of 7. That's our answer. The square roots canceled each other out. So 4 square roots of 28 is equal to 4 square roots of 175. Interesting. All right, so let's look here. We have 98 for x to the fourth y squared, and we want the square root of all that. And then over here we have -3x squared y square root of 2. So let's rewrite this. 49 times 2. We've got 49 as one of our perfect squares. We know if we double it, that's 98. X to the fourth y squared, all of that's under there, minus 3x squared y square root of 2. So if this is 49 times 2, 49, the square root of that is 7. So that means out front, we're going to have a 7. What else can we take out of there? X to the fourth. What's the square root of x to the fourth? Well, if we take x squared times x squared, that's x to the fourth. So that must be the square root of x to the fourth, because that's x times x, and that's x times x, that's x to the fourth. So the x squared can come out because the square root of x to the fourth is x squared. Y squared, well, what equals y squared when you multiply it by itself? That's just y. Square root of 2 stays inside because we can't take square root of 2. It's not a whole number. And then this has already had everything simplified. 3 is already outside, the x squared, the y, square root of 2. So we have 7x squared y square root of 2 minus 3x squared y square root of 2. Notice these are all the same. These are all the same. So if we have 3 of them over here and we're subtracting from the 7 of them, that leaves 4 x squared y square roots of 2. And that's our final answer. Because we've got 7 of them over here. Everything's multiplied by 7 over here. Multiplied by 3 over there. We subtract them. There's just 4 left. All right, here's the last 3 problems we're looking at. And then I'm going to show you the formative assignment. Multiply coefficients and then use the product rule. Multiply coefficients, then use the product rule. So when you multiply the coefficients, this has no coefficients over here, but it's the same thing as whatever the n is, AB. You just multiply the radicands together. If they have the same, they have to have the same sign. This can't be a square root and a cubed root. And then simplify after that. So square root of 27 times the square root of 5 equals the square root of 27 times 5, which equals the square root of what's 27 times 5? 135. So what could we possibly pull out of 135? Well, let's pull up our calculator and we'll give it a shot with a few things. So remember how to do this. If you don't know instantly what perfect cube comes out of that, or what perfect square, I'm sorry, these are square roots, we'll try dividing it by the biggest number possible that we can. So we know it's not 100 is not going to work, 81's not going to work, 64 not going to work. We can do 64 if you want to see it. 135 divided by 64, that's 2.1. That doesn't work. So let's try 135 divided by, we'll move down to the next one, 49. That doesn't work. That's not a whole number. Let's try 36. 135 divided by 36. That doesn't work. How about 25? 135 divided by 25. That doesn't work. None of these divide in evenly. Let's keep going. 16. 135 divided by 16. That does not divide equally. When you're running out of numbers, 135 divided by 9. 9 times 15. So this is the same thing as the square root of 9 times 15. All right, so we know 9 is a perfect square. So this is the same thing as 3 square roots of 15. We can't take the square root of 15. It's not, there's no perfect squares in there. but that's what it equals. All right, let's look at another one. I don't know if we'll need to calculate or not, but I'll leave it up here just to see. All right, 3 square roots of 10 minus 2 square roots of 18. 3 square roots of 10 minus 2 square roots of 18. So that would rewrite as 3 times what? Oh, there's a multiplication in there. I'm sorry. These are multiplying. Got to do that first. So 3 times negative 2 is the coefficients. We have to multiply the coefficients. And then multiply 10 times 18. Square roots of 180, right? 10 times 18. So that means that's the same thing as negative 6 square roots of 180. But what can we pull out of the 180? Let's go back and look at our perfect squares again. Well, 10 is not going to divide in there. 81 is not going to divide in there because it's going to be 2 point something. 64 is not going to do there. Or we can go back to our calculator here. 180 divided by 64. That does not divide equally. Let's try 49. 180 divided by 49. No. 180 divided by 36. Oh, that didn't work. So this is the same thing as negative 6 times the square root of 36 times 5. Because when we divided 36 in there, it gave us 5. So those two numbers multiply together to give us 180. So 36 times 5. 36 is a perfect square. It's 6 times 6. So that means negative 6, and then we take a 6 out. Negative 6 times 6, square roots of 5. So negative 36 square roots of 5. That's what it simplifies down to.
There's another video I want to show. Sorry, guys.
And this one was 3 square roots of 15. All right, one more. And this last one we're going to do over here is with cubes. All right, so cubes. 2 cube roots of 9 times 5 cube roots of negative 24. So let's multiply them together. So 2 times 5 is 10. And then the cube root, 9 times negative 24. Well, let's put that in our calculator. 9 times 24 negative. 9 times negative 24. That's negative 216. So let's look at our cubed roots. Cubed roots. Perfect cubes. 1, 8, 27, 64, 125, 216. This is a perfect cube. We're going to be able to eliminate the cube root altogether because the cube root of 216 is 6. With that negative, if this was a squared, we'd end up dealing with an I, right? Because the square root of negative 1 is an I. But this is a cubed root. If you take negative 6 times negative 6, that's a positive 36, right? And then multiply it by another negative 6. 6 times 6 is 6. Carry, what am I looking at? 216. Carry the 3. 3 times 6 is 18. Negative 216. So negative 6 times negative 6 times negative 6 equals 216. So this simplifies to 10 times negative 6 or negative 60. We don't have to use a third root because it went away. We found the third root of negative 216. It's negative 6. So remember to use your chart and divide the biggest number you can out of it. If I can divide a 216 out, that means that comes out as a 6 if it's a cube root. On a fourth root, if I've got 2401, that's just 7 times 7 times 7 times 7. So that comes out as a 7 for a fourth root. But I don't think there's any fourth roots. Oh, there's some fourth roots over here. So this does have some fourth roots. So let's look. Get rid of that. Let's look at our assignment. Converting radicals and exponents. This first section, 1 through 5, write each expression in radical form and simplify as needed. X to the 1/4 power, 15n in parentheses, all raised to the half power, 7 to the 2/3, k to the 7/2. Okay, so these first 5 are all like the first problems that we worked. Then you go to the next section, write each expression in exponential form. It doesn't say you have to simplify this. You're just writing these with an exponent. 16 to what power would be the same as the cube root of 16. XY to what power would be the same as the square root of XY. Okay, so there's those problems there. Then we have rewrite all radicals in exponential form, use the rules to simplify it, and write your answer as a radical. That's like we were doing on those problems on the second page. M to the 5 seconds over m to the 7/4. This is already in an exponent, so you don't have to rewrite it. But what's the rules say? Remember, the rules say when you're dividing, you can just subtract the exponents. So that would be m to the 5 second minus 7/4. So figure out what 5 seconds minus 7/4 is, come up with one answer, and then rewrite it as a radical. As a radical. Emphasize that. Answer as a radical. So you got to make it with the radical and the radicand in the index. There's two more that are already exponents. These are already exponents. Now this last one is a radical. So you're going to have to convert it to an exponential and then simplify it and then put it back as a radical for your answer. And then this last one, last section, adding and subtracting radicals. That's what we're doing. You got to have the same radical. They both have to be the square root of 3. Can you make this into a square root of 3? Then you would add them together. This one is subtracting. They're all square root in this case. These are both cube roots. These are both fourth roots. Then there's multiplying. 2 cube roots of 3 times the cube root of 27. And this is distributing, so you got to multiply it times the other one as well to distribute. 2 cube roots of 3 minus 8 cube roots of 6. And then here's two binomials you're multiplying together. 10 times 10, 10 times the negative 3 square roots of 7, positive 3 square roots of 7 times 10, and 3 square roots of 7 times negative 3 square roots of 7. Now let me show you, we'll go back to the very first one. I'm going to show you how to write this with like a third root or a fourth root. Some of you did not pay attention to that in the video I made or in the last class, but I talked about that. So to write it as, you got to go, this is the screen that pops up. If you click this f of x, you have a whole different menu of stuff. All of these have a different menu of stuff that you can use. But we want to go to this f function menu. And right here in the middle, on the third row, is this button right here. If I click that button, it gives you a place to type the index. So I can say, oh, this is the third root of, I could say k squared if I need to. But it's got a place to put that third root right up there. I know it's really small on the screen here, but if you have it on your computer, you'll be able to see that. You can change that to a third root. Does it need to be a fourth root? Does it need to be a fifth root? Whatever. So square root is all that shows up on the first page. You have to switch to the second function menu to use the one where you get to type your own. Type your own. All right. So make sure you're using that for your answers in there. Use that. Square root, you don't have to do it with, you can use this for square root because that is square root. Square root of 2. Then we said times, and you wanted a cubed root of 4, So use that button. All right. Any questions on that? I'm going to erase that because that's totally the wrong answer, but I typed it in there just to show you how to do that. Okay, I'll have this video posted a little later if you need to review how I did some of those problems. When you get in one of these sections, it's like, oh, I forgot how we did that. If you want to go back and look at my notes. Like I said, these notes are in Google Classroom. I'll take pictures of these and put them in there as well so you can see my completed notes that I used. So you can see my examples that are completed, and those will be in Google Classroom as well.